to get the same formula for the slope of the tangent line, but when the curve is given in polar, we just have to remember how we can write a polar equation in parametrics. So let's say the polar curve is r, that depends on the angle. And so we can say that in parametrics that is going to be x is going to be equal r, that depends on the angle, times cosine, and y is going to be r times sine. So the only thing is that the r, we know that is an r that depends on the angle, but otherwise is the idea that x is r cosine and y is r sine. Now we have to apply the same formula that we knew for parametrics, because now our curve that was in polar, so is in parametrics. So we are going to say that the derivative of y respect to x is going to be the derivative of y divided the derivative of x. So in the numerator, we are going to put the derivative of y, and y is this one. So let's observe carefully how y looks like to know how the derivative is going to look like. So y is a product, r times sine. So it's a product of two functions. So the derivative, in order to calculate the derivative, we have to use the product rule. Also, observe that this function that we have here is a function that is not concrete, right? So we are doing it in general. We don't know what function is. That will depend on each case. So we have to take that into consideration. Whilst this one is just sine of theta. So that one we know exactly what function is. So by the rule of the product will be the derivative of the first one, we just put here r prime, times the other one just as it is. So it will be times sine, plus the first one as it is, that will mean r, times the derivative of the second one, that will mean cosine. And we do the same for the second one, for x. So the derivative of x is going to be in the same way. I'm just having into account that when we have to calculate the derivative of r, we are going to put just r prime. In each concrete case, we will calculate the concrete derivative. So the derivative of x is going to be the derivative of the first one times the second one as it is, cosine, and so plus r, the derivative of cosine, that is going to be minus sine. So we can do the multiplication here and just put a minus instead. So that will be r prime cosine minus r sine. And this is then the formula for derivative in polar. So observe all the things that we need then to calculate the derivative in polars. We need the function, whatever function we have, and we need the derivative of the function. Otherwise, the sine and cosine belongs to the formula, will be always there. So essentially, in order to calculate a derivative in polars, we need to have the function and the derivative of the function. So let's use this formula in this example. So the example is, then find the slope of the tangent line at this particular angle, pi over 2, and the function that we are talking about is r equal 1 minus cosine. So this is the curve that you can actually graph in polar. You may remember that if you try to graph this curve, is the one that looks like a heart, is the cardioid. And so, in particular, we are trying to calculate the slope of the tangent line at the cardioid when the angle is pi half. So pi half will be about here, this point, and so we are trying to calculate what is the slope of the tangent line there. Okay, so let's start by just applying this formula. So the derivative of y respect to x will be equal to, in the numerator we are going to put r prime. So we know that r is this. So r prime is just sine. Okay, and so times, now we continue like in the formula, times sine plus, now we put r. R is just 1 minus cosine, right? So whatever we have given as r. And times cosine. And in the denominator, we do the same. R prime, which is the same thing that we put before, right? So R prime is sine times cosine minus, now R, which is 1 minus cosine times sine. And that's it. This is the derivative. I mean, we can do the algebra here, eliminate the parentheses, but essentially this is the derivative. By doing the algebra, we get that this is sine squared plus 1 times cosine. This is just cosine minus cosine times cosine. This is cosine squared. And this in divide by sine cosine minus sine so putting together here will be minus sine, and when we multiply this will be sine cosine. So we have sine cosine plus sine cosine. This is the 2 sine cosine, and the sine at the end is just 1 multiplied by sine. Okay, so this is the derivative. I mean, the derivative that we have to calculate is equal to this. So we have the value of the derivative for any value of the angle. So we could calculate the derivative at any point here of this curve. In this problem, we are asked to calculate at angle pi over 2. So let's evaluate this function that we calculated in general. Let's evaluate at pi over 2. So let's substitute here every time that appear the angle, let's substitute by pi half. So sine of pi half is 1, square is 1, cosine and cosine squared, these are both 0. And so in the denominator we have 2, all this part is 0, and so we have minus sine of the angle, which is 1. And so at the end of the day, this is minus 1. This is the slope of the tangent line, which makes sense with the slope that we are seeing there, right? So we see that this blue line here is going down with a slope approximately 45 degrees. That's what it means to have a slope minus 1.